Hello everyone. Today we'll talk about credit card fraud detection. With the increasing popularity of online shopping, electronic payment, and digital banking, the volume of credit card transactions has surged. Our project aims to build a strong supervised learning classification model for detecting credit card fraud. Our methodology consists of 5 parts. First, we perform data processing and feature engineering. Then, we apply sampling techniques to balance the dataset. After that, we proceeded with model training. Next, we focus on model modification and tuning. Finally, we evaluate our model using key metrics. We choose 30 features from the raw data based on their correlation of the target variable and then transform and normalize them. In the sample section, we know that the credit card fraud detection is a problem. It's a typical balanced problem. The imbalance can lead to significant bias in our classifier, so we need to use sampling method to address it. To tackle the imbalance problem, we can use undersampling or oversampling. Undersampling reduces the number of majority class instances, while oversampling creates synthetic samples for the minority class to balance the dataset. We decided to focus on the oversampling for our main approach. We experiment with 2 techniques, random oversampling and smooth, and then compare their results. Smooth is an oversampling technique that creates new sample for the minority class. It works by selecting a sample and finding its k nearest neighbors. Then, it generates a new data point between the original sample and its neighbors. This approach helps boost the model performance and reduces bias towards the majority class. Logistic regression is typically designed to solve the binary classification problem selected as our candidate model. It applies sigmoid function to express prediction in the form of probability, use cross entropy as a loss function, and adopts the L1 or L2 regularization term to minimize the model bias. 2 tree-based models are selected in our projects, decision tree and random forest. As the picture shows, the decision tree model basically tries to find the best splitting point for our samples. To evaluate the splitting point, decision tree usually use the intrusive loss or Gini impurity as a measurement. Random forest, based on the decision tree, adopts the banking method that samples data with replacement and creates multiple decision trees to jointly make the prediction. Cross-validation technique helps us to estimate the more accurate performance of our model and allow us to apply the grid search method to find optimum hyperparameters that are tailored to our problem. According to the research result, we identified these hyperparameters that are listed in this table. Our models are trained in this setting for the following experiments. Multiple metrics are defined for assessing the performance of our model. Recall measures the ability of the model to correctly identify risky client out of all actual positive instances. The F1 score is a harmonic means of precision and recall. The ROC curve and AUC are used to evaluate the ability of discrimination on our models. In terms of the sampling method, without sampling, all methods show very low recall and F1 scores, indicating significant difficulty in identifying fraud. Random oversampling offers slightly improvement for logistic regression and random forest classifier, but F1 scores remain low. Smooth oversampling significantly boosts performance, with decision tree achieving higher recall and random forest seeing substantial F1 score increases. In terms of the classifier models, although decision tree shows a very high recall value, but its F1 score and AUC are much lower than the other models. Logistic regression shows a good result in F1 score. However, it does not capture enough pattern of the risky clients. Although random forest still suffers the outfitting problem like decision tree, it is overall great on our metrics in terms of the F1 score, recall, and AUC. In summary, smooth oversampling enhances model accuracy and reliability in our tasks, making it a recommended approach for addressing data imbalance. Random forest is the overall best model for our tasks. It shows a better capability of capturing risk client in complex datasets. Logistic regression has its own advantage compared to the tree-based model, such as high precision and less overfitting, which could be used in the problem with low dimension feature. While the model achieves a reasonable F1 score, indicating a balance between precision and recall, it is important to note that the precision is not high. While the model may perform well on historic data, it might struggle to detect new fraud pattern and new attack method. Our future work is to investigate more feature in engineering technique, such as transaction embedding and temporal pattern. Thank you for watching.